Excellent guys, now I know that this video has been going on for a little while already, but there are a couple more things that I absolutely must introduce you to before we finish this lesson. And these are to do with exact values. Now these things you're going to see over and over and over again throughout this topic, so it's really important that you stay tuned for the next 15 minutes. Alright, so the very first thing is you've been looking at this thing called the unit circle already, and that's going to help you out with exact values. But then there's these two other guys called the special triangles. Alright, and these things here are going to help you out lots over the next couple of lessons. So let's go now and have a look at a little bit of an introduction to working with these two guys. Let's check it out.
Now there's one more thing that we need to cover when going through and working with the unit circle and using exact values within trigonometry, and that is what we call the special triangles. Now those are these two little fellas down here. That is the short little stocky one that you can see on the left hand side, and also the tall lanky one that you can see here. Now what's special about these? Well, it actually gives us exact values for different angles when we sub them into sine, cos and tan, etc. Now, let's have a look at these, shall we? The very first thing, the very first triangle, now what's special about this one is it's got the same base length of 1 as what it does the height of 1. So as you can see here, both of these sides are the same size. Now, what also makes that special is the fact that these are both 45 degrees. So we'll go through here and write 45 degrees and 45 degrees, like you can see here. Now if we're going to go through and figure out the length of the hypotenuse, well, to do that we could use Pythagoras' theorem, of course, where this here is C, this here is A, and this here is B. So let's go through and find out the hypotenuse. So to do that we're going to go C squared is equal to A squared plus B squared. And of course, let's go through and substitute our A and our B value now. So we're going to get C squared is equal to 1 squared plus 1 squared, which is going to be equal to 1 plus 1, which of course is equal to 2. Therefore, C squared is equal to 2. Now if I want to find what just C is, well that therefore is going to be C is equal to the square root of 2. So therefore, on this side here, the hypotenuse will be a length of root 2. Now let's have a look at the tall lanky fellow over on the right. Now as you can see here, we've got a long side here, a longer hypotenuse, and a short side here. Now for both triangles, the base is equal to 1. Now the other thing that you need to know is that this hypotenuse is twice the length of this base, so therefore the hypotenuse will be 2. Now the thing that makes this special as well is because we know that the hypotenuse is twice the size of the base, it means that this degree in here is twice the size of this degree, or this angle. So therefore that's going to be 60 degrees and that's going to be 30 in order for all interior angles of the triangle to add up to 180. Now, because I know that that's 1, that's 2, well what's that going to be? Well, once again we'll use Pythagoras' theorem to figure it out. So you're going to get C squared is equal to A squared plus B squared. And of course this is going to be our C, this is going to be our A, and this is going to be our B. So let's go through and substitute that in now. So we've got 2 squared is equal to 1 squared plus B squared. 2 squared is 4, 1 squared is 1 plus B squared. Now let's subtract 1 from both sides, so that's going to get us 3 is equal to B squared, and therefore when I go through and solve for B and get it on its own, that is get rid of the square, I'm going to get B is equal to the square root of 3. So therefore this length here is going to be root 3. So let's go through and neaten this up a little bit, shall we? I'll just delete everything. So as you can see, both of our special triangles are going to have a base length of 1. And then for this triangle here, well, it means the height has got the same length as the base length, and therefore you're going to get 1 root 2, with both of these angles being 45 degrees. Now for this one here, well, it's the same as saying 1, this is twice the length, so it's 1, 2, and this becomes root 3, so 1, 2, root 3, with this one here being 60 degrees, and this one here being 30 degrees. Now it's essential that you remember how these triangles look because you're going to need them over and over again throughout this topic. And you're going to have to remember how to do them when attempting questions that do not permit the use of a calculator. Now the next thing you need to know are the steps to follow when working with the unit circle and special triangles. Now the very first step is draw out the special triangles at the top of every page. So that is, you need to make sure that you draw these two triangles at the top of every page, just so once again you remember how to do them when you don't have your notes in a test or an exam. And then the next thing you need to do is draw out a new unit circle for every question, and draw a line in the correct quadrant to show the angle and determine whether your answer will be positive or negative. So let's go through and I'll show you what I mean by that. Alright, so it says find the exact values of sine of 270 degrees, cos of 540 degrees, and tan of 90 degrees. So before I even do that, what I'm going to do is go through and draw out my unit circle for each example. Excellent. Now for sine of 270 degrees, let's go through and actually draw where the 270 degrees will be. So if we go all the way around, the line will end up going down here like so. So that is from there to there, will get us 270 degrees. Now for sine, well sine is along the y-axis, isn't it? So sine of 270 degrees, well it's going to go all the way down to -1. So therefore sine of 270 is equal to -1. Now for cos of 540 degrees, well, that's going to go all the way around to 360, but it's more than 360, isn't it? So therefore, cos of 540 is actually equal to cos of 360 plus 180. Now, because of that, it's going to go all the way around to 180 again. So therefore, our line's going to come out to here, like so. So that's going to go once around to 360, and then halfway around again to 180. Now cos of 180, well that's on our x-axis, and therefore it's going to get us to -1. So therefore cos of 540 is equal to -1. Now tan of 90 degrees. So tan of 90 degrees is here. And tan, well we want to find out whereabouts this line here will touch along this line. Now because they're going parallel, they'll never actually touch. So the thing about tan of 90 degrees is that you'll actually get an undefined answer. Now if we think about that for a second, well we know that tan of 90 will be equal to sine of 90 over cos of 90. Now what's sine of 90 equal to? Well it's equal to 1, and cos of 90, well that's going to be 0, isn't it? And of course 1 divided by 0 is undefined because you can't actually divide by 0. So now what I want you to do is press pause and attempt the following questions, that is cos of 90, sine of 450, and tan of 540. Now remember when you're done to press play and check your answers out against mine. Excellent, so welcome back. Now if we have a look at cos of 90, well as you can see here, the line has gone from here all the way around to here, so therefore cos of 90, well my x-axis is at 0 for there, so cos of 90 will be equal to 0. Now for sine of 450, well that's the same as saying sine of 360 plus 90, so that is I go from here all the way around and then 90 degrees past 360. Now for sine, well how high up the sine axis is this point? Well it's at 1, isn't it? So therefore sine of 450 is equal to 1. Now for tan of 540, well that's the same as saying tan of 360 plus 180. So what I do is I go here all the way around to 360 plus 180, and that's going to get me around to this point here. Now how high up along this imaginary line is this point here? Well it's at 0, isn't it? So therefore tan of 540 is actually equal to 0. Now another way to prove that is actually to go tan of 540 is equal to sine of 540 divided by cos of 540. Now sine of 540 will be 0, as you can see, because it doesn't go up anywhere for this point here. And cos of 540, well that's -1. So you end up getting 0 divided by -1 is equal to 0.
Cool, so I guess it's time to now have a look at some worked examples on how to actually work with these special triangles. So let's check it out.
Now in these examples we're going to use the special triangles in order to help us to find the exact values of cos of 45, sine of 60 and tan of 60. So let's go through and have a look at these first, shall we? Let's do cos of 45. Now whenever I'm working with 45, 60 or 30 degrees, I need to look at which triangle is going to be the most appropriate. Now as you can see, because it's 45, triangle number 1 is going to be the most appropriate. So I'll just go through and draw out triangle number 1, which of course is 1, 1 root 2, and 45 degrees, and 45 degrees. Now for cos of 45, remember SOHCAHTOA, that is sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. SOHCAHTOA. So because I'm looking for cos, I'm going to deal with adjacent over hypotenuse. So I'll write cos theta is equal to adjacent over hypotenuse. Now, if I have a look at my theta, well let's use this 45 degrees. It could be either because it's going to give us the same answer, but we'll use this one. So therefore, cos of 45 is equal to adjacent, so it's going to be the 1 over the hypotenuse, which is root 2. So therefore cos of 45 is equal to 1 on root 2. But we cannot have an answer where we've got the square root on the bottom, so what we need to do is rationalize it. And to do that, what we need to do is multiply both the top and the bottom by root 2. So that's going to get us 1 times root 2 is root 2, and root 2 times root 2, well, that's the same as saying 2, because the square roots will cancel each other out. So the answer for cos of 45 is equal to a root 2 on 2. Now for sine of 60, well, which triangle am I going to use? You can see here that I've got my 60, so therefore I'm going to use triangle number 2. So let's go through and draw that one out, like so. And of course I've got 1, 2, root 3. My little right angle there, that's going to be 60 degrees, and that there is going to be 30 degrees. Alright, so I'm working with 60 degrees, and it's sine, so I come up here, so it's going to be sine theta is equal to opposite over hypotenuse. Now therefore sine of 60 is equal to, well, let's have a look at the sine of 60. So sine is going to be opposite over hypotenuse, so it's going to be root 3 on 2. So your answer for sine of 60 is equal to root 3 on 2. Now for tan theta, or tan of 60, let's go through and draw out the triangle that's appropriate again. So therefore the triangle that is appropriate is the one with the 60, so we'll draw the same one out again, triangle number 2. I've got 1, 2, root 3. That there is 60 degrees, that there is 30 degrees, and now what I need to do is figure out what tan of 60 is going to be. So I go tan, and tan is equal to opposite over adjacent, because TOA, so tan theta equals opposite over adjacent. Therefore tan of 60 is equal to opposite, well, let's have a look at our 60. Our opposite is going to be our root 3 over our adjacent, which is 1. Now root 3 divided by 1 is equal to root 3. Therefore tan of 60 is equal to root 3. So now it's time to press pause and attempt the following questions. That is, find the exact values of cos of 60, sine of 45, and tan of 30. Remember, when you're done, to press play so you can check your answers out against mine. And what I recommend you do is go through and draw out the special triangles for each one just to get into the habit. Excellent, so welcome back. Now as you can see, for cos of 60, what I've done is chosen the triangle that had 60 degrees in it, and I've got my 60 degrees here. Now for cos, it's equal to adjacent over hypotenuse, so my adjacent is 1 over 2, so therefore cos of 60 is equal to 1 over 2. Now for sine of 45, I've chosen my triangle that has 45 degrees in it, and for sine of 45, well, it's equal to opposite over hypotenuse, so my opposite is 1 over root 2, so therefore you get sine of 45 is equal to 1 on root 2, and of course to change that into a rationalized fraction you need to go multiply both sides, that is the top and the bottom, by root 2, so that's going to get you root 2 on 2. And finally for tan of 30, what I've done is I've got the triangle that had 30 degrees in it, and for tan it's opposite over adjacent, that is your opposite here over your adjacent here, so you get tan of 30 is equal to 1 on root 3. And of course, because I've got my square root on the bottom, I need to rationalize it by multiplying both the bottom and the top by root 3, which gets me root 3 on 3.
Excellent, guys. Thank you very much for tuning into today's lesson, which was all about the unit circle and the special triangles. Now, it's really important that you stay tuned for the very next lesson, because we are going to have a look at how to convert between degrees and radians. That's right, there's actually another unit of measurement for angles, and that's called radians. So we're going to look at how to work with both of those. Alright, now like always, make sure you say hi to your maths teacher for me. Morsey out.